OECD guidelines 420, right? So there are so many guidelines it has given by the OECD. In that, basically, these guidelines it is designed for the what do you call toxicity study of any of the chemical compound or any of the chemical moiety. It may be for the new drug or it may be for the existing drug. Like basically when we are trying to know what is the kind of toxicity it is going to have when we are going to check, so there is a guidelines or rules and regulation has been framed by the different governing body existing throughout the world, right? So what is the kind of animal we are going to take, what how the cutoff value we are going to find out, what is the lethal dose 50, what is the effective dose 50, for those things how we are going to test like fixed dose, so many things it is there, so that we are going to basically brief in this today's class, right? So coming to the toxicity of OECD guidelines 420. So in that first of all, what is OECD, right? So OECD it is nothing but Organization for Economic Cooperation and Development. That's what OECD, right? So you are going to be familiar with this particular OECD because whatever the kind of activity you are going to do in the tenor of your research, right? So first of all, you need to find it out that whether the particular chemical compound or extract it is having already toxicity study or not available or not. That literature, if it is not available, definitely without toxicity study you cannot go for any kinds of activity or any kinds of therapeutic property determination, right? So that's what OECD is an intergovernmental organization, right? So basically it is located in Paris, France, right? So it is the head office, the main office it is there in that country, but the rules and regulation it is being implemented in throughout the 29 countries. That's what representatives of 29 industrialized countries in North America, Europe, and the Pacific, as well as in the European Commissions meet to the coordinate and harmonize policies, the rules, the regulations, right? And discuss the issue of mutual concern and work together to respond to the international problems related to the toxicity or related to the any kinds of toxins, right? So that's what this particular body it has been framed. The main intention, the objective of this OECD, it is whatever the guidelines like 401, 420, 423, 425, which we are going to discuss, right? So that is basically for that reason only, right? That's what we are discussing here. The original guidelines 420 was adopted or implemented in July 1992, right, as the first alternative to the conventional acute toxicity test, right, described in test guidelines 401, right? So whatever 401 it has come first, then 420 it was adopted or implemented or come into the effective in 1992, right? How it has come? Based on the recommendations of several expert meetings, right? Revision was considered timely, right? So it is not that the 420 whatever we are using today it is suddenly it has been a few people have gathered and they have designed the rules and regulation which what kind of mice we are, which strain of mice we are going to take, what is the from which dose we are going to start. No, it is revised time to time. Now also whatever the existing guidelines it is there, we cannot say that tomorrow also it's the same thing it is going to implement. That's what the alternative system it is keep on implementing day by day. We are trying to reduce the uses of animal or sacrifice of the animals, right? So that's what so what is the reason why it has been revised? The international agreement had been reached on harmonized LD50 cutoff values for the classification of chemical substances, right? That was which differ from the cutoff recommended in 1992 version of the guidelines. That was the one reason. And testing in one sex or one kinds of like female, usually females it is being used because female strain it will be more sensitivity, and whatever the result we get that we can consider as a the same result it is going to have into the human body or into the some other organism, right? So that's what it is now considered as sufficient. So because of these two reasons, it has been revised. So generally, when we see the traditional method of assessing acute toxicity, use death of animals as an endpoint, right? So generally, it happened. The animal, whatever the animals, whatever the mice we are using, ultimately they are reaching to the death level, right? So at the end point, then only we are going to consider that 50% of the population, if it is dying with the particular dose, that is called LD50, right? So that happened generally in traditional. In 1984, a new approach to acute toxicity testing was suggested. By whom? By the British Toxicology Society, based on the administration at a series of fixed dose levels, right? So that's what this particular suggestion, it has been approached, and later on it has been implemented or revised. The approach avoided using the death of animal as an endpoint. The intention, the motto, the objective was like we can avoid the death, right? At the same time, we'll be able to determine the dose, in which dose it may be toxic and which dose it may be used as a therapeutic dose, right? That's what. And the relied instead on the observation of clear signs and symptoms of toxicity at one of the series of fixed dose level, right? That's what it is being implemented. And following UK and international in vivo validation studies, the procedure was adopted by the council as the test guidelines in 1992. That's what, for 20 guidelines it was implemented, or it came into the effect on 1992. Subsequently, the statistical properties of the fixed dose procedure have been evaluated or screened using the mathematical model in a series of studies. Instead of using the animal, once if you get one reading, the remaining thing can be assume or with the method. That's what in the COVID-19 time we have determined the R naught for the particular variant of the virus. In the same way, we have the mathematical model, and we can assume that if it is giving in this dose this result, so further it will give in the this. So that will be clear into the further what exactly the 420 guidelines. So you will come to know from which dose we are starting and from which dose we are concluding, right? Together, in vivo and the modeling studies have demonstrated that the procedure is reproducible, uses fewer animals or less number of animals, and causes less suffering. Also, it's important how painful, how discomfort they are feeling during the study. That also we are trying to minimize here, right? Then the traditional method, generally in traditional method we don't bother, and they ultimate definitely they are going to be killed. So that's what, to minimize that one, and is able to rank substances in a similar manner. At the same time, we are not going to compromise, like if we are not using the animal, so we are not getting the data, we are not able to find out the authentic data, why authentic dose. That also should not happen. Similar manner to the other acute toxicity testing methods, test guidelines 423 and 425 also it is there, right? So how it is going to have, that we are going to discuss. So when we talk about the 420 guidelines, initial consideration what we are going to have, right? So what are the points basically we are focusing, or the governing body has been focused and formatted the regulations or rules. It is a principle of the method that in the main study only moderately toxic doses are used, right? Not severe or not mild, moderate, right? Medium toxic doses are used, and that administration of doses that are expected to be lethal should be avoided, right? So that's what, whenever we are giving any dose randomly, if you are selecting, right? So that dose should not be lethal, means animal should not die first of all, that we need to take care. and at the same time we will be able to determine by the signs and symptom that it may be lethal, or that's what severe lethal can be avoided. Also, the another point, another consideration, also doses that are known to cause marked pain. What is the dose? 500 mg, 700 mg, 1000 mg per kg, that if it is known which can cause the marked pain, or which we can say ki that this particular mice, it is feeling the pain, or it is getting the pain and the distress or discomfort due to the corrosive or severely retained actions, need not be administered. That is also into the consideration, right? So to avoid that also, it has been modified or reframed. Then the moribund animals, or those animals, or animals obviously in pain, already it is having some kinds of discomfort or showing the signs and symptom of severe and enduring distress, shall be humanly killed. What is the mean of humanly killed? By giving the anesthesia, and there is a proper way to kill the particular animal. We cannot just kill by the how we are killing the in other way, right? So that's what humanly killed has to be there, and are considered in the interpretation of the test results in the same way as animals that died on test, right? So that also can be considered. Criteria for making the decision to kill moribund or severely suffering animals, and the guidance on the recognition of predictable or the impending death are the subject of a separate guidance document, right? So these are the consideration has to be taken care. So what is the principle of the test of OECD guidelines 420? The principle is that groups of animals in a single sex are dosed in a stepwise procedure using a fixed doses of 5 mg per kg, 50 mg per kg, 300 mg per kg, and 2000 mg per kg. Exceptionally, an additional fixed dose of 5000 mg per kg may be considered, right? So it depends, right? That's what stepwise it is told. We cannot start from 300 mg per kg, right? We cannot start from 5. First, we will see 500 mg per kg of any of the extract which you have got, for example, any plant extract or any oil from animal, any hormone or anything which you want to determine the toxicity. First, we'll see the we'll take the mice, and three number of mice, five number of mice. It depends on the which guidelines we are following. What is our intention? Fixed dose. Suppose if we are doing so, first we'll give the 5 mg per kg body weight dose, and we'll observe the animal, right? So in that way it will go on. That I will tell you in paragraph 19. It is there in the next slide, coming slide. The initial dose level is selected on the basis of a sighting study, right? As the dose expected to produce some signs of the toxicity without causing severe toxic effects or mortality. That is the very important, right? So initial dose level means 5 mg, right? That is the, as per our guidelines, we can go 5, 50, 300, 2000 and 5000 if required, right? So here selected on the basis of sighting study, we have to observe the particular animals, what is the behavior after giving, and as the dose expected to produce some sign, some kinds of symptom which will indicate that some discomfort or something, some uneasy they are feeling, that we have to note it down. Clinical signs means again we have to collect the blood sample and we'll go for clinical signs, that is, and conditions associated with pain, sufferings, and the impending death. All right, sudden death, or sometimes up, right? Sometimes the animal may die because of your chemical, right? Are described in details in separate OECD guidelines document 8 site. So further we can take the details about that. But as of now, you can understand any kinds of discomfort or distress that we have to note down. That's what we should have the clinical evidence, right? That's what what SGOT, SGPT, total bilirubin, cholesterol, protein, what is the kind of disturbance it is there, and like prostaglandin synthesis, inflammation or something like that, we have to have the evidence. Further groups of animals may be dosed at higher or lower fixed doses, depending on the presence and absence of signs of toxicity or mortality or death, right? So it depends. This procedure continues until the dose causing evident toxicity, right? We have to keep on, first 5 we will see, then 50 we will see. So in 50 mg per kg or in between 50 to 300, if we are getting any dose, in any dose the evident discomfort, then we have to know, collect it that, right? No more than one death is identified, or when no effect are seen at highest dose, or when death occur at the lowest dose. We have to observe by giving. So it will very much clear into the chart, I will explain at the end, right? So description of the method, what is the kind of animal we are going to select. First, the selection of the animal species, right? That is important. The preferred rodent species is rat, obviously, right? Sometimes mice we are using, right? Although other rodent species may also be used, normally female are used, because female may rats, it is considered as a more sensitive, and the response it we will get in a very good response, so that can be easy to determine. This is because literature surveys of conventional LD50 test reveal or shows that usually there is little difference in sensitivity between the sexes. But in those cases where differences are observed, females are generally slightly more sensitive. That is the reason behind selecting the female rat or female sex, right? However, if knowledge of the toxicological or toxicokinetic property of a structurally related chemical indicates the males are likely to be more sensitive, then this sex should be used. If what if, suppose if you know the particular about the chemical compound or about this thing, then we can go for, if it is very much new, we should prefer the female rate. Okay. When the test is conducted in males, adequate justification should be provided. That is the given in the guidelines, right? So this question generally it will be asked, why you have taken the female rat, or if you have written in your article or in your thesis that I have taken the male albino rat for the toxicity study, and for OECD 420 I have followed, they will definitely ask why you have selected the male. So from these guidelines, this particular line you can quote and you can justify that the particular chemical it is known, that's what I have selected the male or something like that, right? So this only you have to quote. Healthy young adult animals of commonly used laboratory strain or species should be used or employed, right? Female should be nulliparous or non-pregnant, right? So that's what they should be adult sufficient, and they should not be the like, right? Each animal at the commencement of its dosing should be between 8 to 12 week old. First of all, its weight should be fall in the interval within the plus or minus 20% of the mean weight of any previously dosed animal, right? So there should not be much variation into the weight, much variation into the age, much and first of all, there should not be variation into the sex and strain or species. That's very important, right? So that we need to take care. Housing and feeding condition, that also we should discuss, right? Because it's very, very important that it is not the uh, we should give the very high-fi VIP treatment to those animals, the acclimatization, their fooding, water, and all those things that has to be taken care very properly. Then only we can use them for the research purpose. The temperature of the experimental animal room should be 22 degrees centigrade plus or minus 3 degrees centigrade. Just imagine that temperature, whatever if you are using, you are conducting the your activity into the summer season or winter season or rainy season, doesn't matter, wherever your animal it is housed or it is kept for acclimatization, that should, the temperature should be maintained 22 degrees centigrade or plus or minus 3, right? Although the relative humidity should be at least 30% and preferably not exceed 70%. Other than during room cleaning, the aim should be 50 to 60%. So all those things for a while you can go here and there, but generally this is the guideline. Lighting should be artificial. Why? Because we cannot depend on, because if the 12-hour light, the sequence being a 12-hour light and 12-hour dark, right? So day and night has to be maintained artificially so that they can sleep at night and they can do other activities into the daytime, so that their other physiological process, their digestion, their other things, should biochemical reaction, biotransformation, absorption, distribution, so many things, it can go on properly and it will not interfere into the our result when we are going for toxicity study. For feeding, conventional laboratory diets may be used with an ultimate, the unlimited supply of drinking water, right? So the food, it is very important, the water, it is very important. What is the kind of that they should not feel thirsty, they should, the unlimited water supply should be there, the good quality of food that has been given by NIN, like right. So all those things has to be maintained in the standard one. Animals may be grouped, caged by dose, but the number of animals per cage must not interfere with clear observation of each animal, right? That's what n is equal to 6 generally we are using. And the what is the size of your cage, right? So if you will overcrowded, if they will be there, they will not be find the space to walk, and they will not find the space to the play and all those things. So it will, and moreover, we have to observe each and every chemical animals after dosing, right? That's what the marking should be there properly, though there are so many guidelines into the handling of animals during the study, that also it is there, right? So as of now we should know that they should not be overcrowded in particular cage. Okay. Preparation of animals, right? So what do you call, first of all, they also need to be prepared so that their body is fit for the study or not, that we need to take care. The animals are randomly selected, randomly, right? It should not, right? We have to then mark the to permit individual identification, tail marking, head marking, body marking, so many marking method it is available, right? And kept into their cages for at least 5 days prior to the start of dosing, 5 days before, into the which cage we are going to maintain them until the completion of the study. That cage we have to keep them 5 days before to start the dosing, and to allow for acclimatization to the laboratory condition, right? That's what, immediately from getting it from the animal house or from so and so lab, so we should not start immediately, we need to wait, and we have to adopt them and settle them into the particular environment, their air, temperature, water, humidity, all those things, then we can start the study. If any abnormal behavior we are getting from any of the animal, we can pick them out and we can replace them. That's what this observation is very important before to the study. Preparation of doses, it is that's what we should very much careful with this, right? In general, test substances should be administered in a constant volume over the range of doses to be tested by varying the concentration of the dosing preparation generally. So where a liquid in product or mixture is to be tested, however, the use of the undiluted test substances like constant concentration may be more relevant to the subsequent risk assessment of the substances, and is requirement of some regulatory authorities also. In either case, the maximum dose volume for administration must not be exceeded. That's what it is recommended. That dose I will tell you, 1 ml 100, that's what, right? Normally you can see in rodents, the volume should not normally exceed or go higher 1 ml per 100 gram of body weight. Remember, 1 ml per 100 grams. So what is the weight of your animals? So accordingly we can decide. However, in case of aqueous solution, if you are not using any non polar organic solvent like alcoholic extract or chloroform extract or something like that, aqueous if you are using, we can give 2 ml per 100 gram body weight, right? So this is very important points here to be remember, right, in the preparation of those, right? So remaining other vehicle, we can corn oil or any olive oil or something like that we can use to make the solution so that we can give to the animals easily, and they can swallow it properly. Procedure, generally procedure is very important. Administration of dose, right? What is the route we have to take? The test substance is administered in a single dose by the gauge using the stomach tube. That there will be the needle, feeding needles, different size it is available, or suitable incubation cannula which will be having some band will be there, and in the top there will be the some bulb, so that it will not scratch to their mouth, their tongue, their what you call the tubes, right? So and after reaching to their throat, slowly we can inject whatever the chemicals or extract we want to give to the animal. So that is we have to take care. In the usual circumstances or situation that a single dose is not possible, the dose may be given in the smaller fractions over a period not exceeding 24 hours. Sometimes they may vomit, or they may be not be, they will not cooperate with you to have that particular extract. So in that case we can divide the dose. We can give them time, that they like how the small kids, they will when we are giving them any syrup or any medicines, so because of bitterness or because of the fear, they will avoid to drink. So sometimes we have to wait. In the same way we have to treat this animal also. Animals should be fasted prior to dosing. That's very important. Yeah, right. Whenever we should not allow them to eat, or the food supply should be stopped for a while, right? So that whatever the dosing we are giving, whatever the chemical extract we are giving, it can absorb in a proper way and its maximum, so that we can get the result. With the rate of food but not water should be withheld overnight, right? Food we can avoid, but water should be given, otherwise they may die also. With the mouse, food but not water should be withheld for 3 to 4 hours prior to the study. Following the period of fasting, the animals should be weighted and the test substances administered. After the substances has been administered, food may be withheld for further 3 to 4 hours in rat, and 1 to 2 hours for the mice. Whatever the animal you have taken, accordingly you can stop the giving the food, and again you can resume. Where a dose is administered in fractions over a period of time, it may be necessary to provide the animal with food and water depending on the length of the period, right? So that we need to take care. Then citing study, that's very important. Sometimes citing study, it will help you to determine or stop the study or initiate the study. The purpose of citing study is to allow selection of appropriate starting dose for the main study, right? That's what, before main study we have to do the citing study, just to see like from where we can start, whether we can start from 50 mg per kg, or we can start from 300 mg per kg. What is the kind of chemical, what is the kind of extract we have, accordingly. So that's what the chemical substance is administered to single animals in a sequential manner, following the charts annexer 2 that I'm going to discuss in the coming slide. The citing study is completed when a decision on the starting dose for the main study can be made. Okay, so that's what starting dose for the citing study is selected from the fixed dose level of 5, 50, 300, 2000 mg per kg, right? So in this, which we are going to pick, from where we can start as a dose expected to produce evident toxicity based, which we can say evident toxicity, right? When possible, on evidence from in vivo or in vitro data from the same chemical and from structurally related chemicals. In the absence of such information, the starting dose will be 300 mg per kg for citing study. Okay, first we will give 300 mg per kg, and we will observe the animal whether they are showing any discomfort, uneasy, or some kind of thing. Then if they are not showing, we can increase towards the 2000. If they are showing, we can decrease toward the 50 mg. So likewise we have to decide a period of at least 24 hours will be allowed between the dosing of each animal. All animals should be observed for at least 14 days. Exceptionally, and only when justified by specific regulatory needs, the use of additional upper fixed dose level of 500 mg per kg may be considered. For reasons of animal welfare concern, testing of animals in GHS category 5 range 2000 to 500 mg per kg is discouraged because of the because animals are dying, and should only be considered when there is no strong there is a strong likelihood that result of such a test have a direct relevance for the protecting human or animal health, and so on, right, for the environmental point of view. Here is the point we need to understand. This is the annexure 2 for 420 guidelines, right? So you can see here starting dose 5 mg per kg. That's what 4 digit you need to remember: 550, and then 300, and 2000. Further 5000, but 5000 generally I just now I told it is not used. So here we are going to start 5 mg per kg. So the one animal 5 mg per kg, right? So it is citing study. That's what we are taking, only one animal, just before the main study, just to check randomly, just rough checking. That's what. So 5 mg per kg if we give, so what three condition may arise. The A, B, and C. What are these three conditions? A is death, B is evident toxicity, and C is no toxicity. Okay. So what is happening here? If we give 5 mg per kg in that for one animal, either the animal will die. If animal will die, we will conclude here main study is starting dose whatever mg 5 mg per kg, it will be considered as a for the main study. Or if it will show any toxicity but they will not die, they are showing the toxicity symptoms, signs, but they will not die. So in that case, what we'll do, we'll keep them in this category. Okay. Then the another condition may arise. The in all the in the that animal, the here we cannot say all, only one animal. That animal, it is not showing any toxicity after getting the 5 mg per kg of the dose. It is playing, right? So what we can do is we can go to the 50 mg per kg. That's what from C we can take this into the next barrier or next dose, that is 50 mg per kg. After giving the same with the same animal, after giving this dose, again three conditions may arise: either animal will die, or animal will show the sufficient toxicity symptom, or animal will show no toxicity. If animal will die, this dose it will be considered for the main study. If it will not, it will show, this will say the 50 mg per kg, it is showing the toxicity, so this dose will take. If there will be no symptoms, no toxicity, further we will take to the next zone, that is the 300 mg per kg, right? So likewise it will go on. And the second starting dose where we will not give the 5 mg per kg directly, we will give the 50 mg per kg. That's what start button, it is there here, 50 mg per kg. From here we will after giving the 50 mg per kg dose, again three conditions will rise: A, B, and C. Either animal will die. If animal will die, we will reduce the dose and we'll go towards the 5 mg, because 5 to 50 there is a lot of difference. 50 to 300 there is a lot of difference in between there are so many digits are there, so many dose it is possible. So if animal will not show any signs and symptom with 50 mg per kg, we will go towards 300 mg, and then further we will go to the 2000 mg per kg, right? So likewise we can do, this is the second condition. Third condition, directly we can start with the 300 mg per kg, and further if we are not getting any sign and symptom, we can go back or we can go forward. Here 2000 mg also we can start, then we can go back. So this four barrier, it is not necessary that 300 mg per kg only will be what you call your toxicity dose or your toxic dose. It may be in between, like 350 mg per kg, 400 mg per kg, 700 mg per kg, because 300 to 2000 there are a lot of digits. 300 to 50 mg there are a lot of digits. So we have to determine, that's what we can go back and write. So in this way it will go on, right? The main study, when we talk about, so when we talk about main study, what will happen? Sorry. So in many study, number of animal and dose level that we have to here we are going to increase the number of level. In setting study, we have taken only one animal. Here we are going to take the 3 animal. The action to be taken following testing at the starting dose level indicating by the flow chart. One of 3 action will be required. Either group stop testing. So this way it will go on, right? So coming to this one, you can see the main study. Main study, the annexure 3 it is called, right? Flow chart for the main study. Starting dose 5 mg per kg. Again, here we are going to take here 5 animals. It is there in main study. There it was 1 animal, right? So 5 animal. Again, we are going to start with the 5 mg per kg. There will be 3 conditions A, B, and C. A means death. That's what 2 or more than 2, right? So that's what we can say, it is the death category. And 1 or less than 1 with the evident toxicity, or maybe 1 it is death, that will be condition B. And condition C, there will be no toxicity. So that's what 50% population should die. That's what it can be, LD50, right? Lethal dose 50. So that we are going to determine. So here, if no toxicity we are observing, again we will go to the 50 mg per kg. If we get any death, we will stop there only, and further we can go back. And if no toxicity, again it will go to 300 mg and 2000 mg. The second condition, starting dose will be 50 mg per kg, and so on we will go on, right? So this is the main study. Here the problem, here the advantage is, in citing study, what dose we have got, and from that dose we can start directly. This one we can take, or we can take this one. That here you can see it is starting in 300 mg per kg. Start button is here, and in this condition start button is in there in the 2000 mg per kg. So these, which one we are going to adopt, that will be determined by the citing study, where 1 animal we have used, and that will tell you the from how you can start the study. Okay, so then you will get the which dose it is toxic dose, and which dose we can have the effective dose. Whatever the dose we are getting, like for example, you are getting 300 mg per kg. In 300 mg per kg, all the animal died, okay, at the same point. So there or in 2000 mg per kg, so 1/10 part of the particular lethal dose we can consider as a effective dose, right? That's what 200 mg per kg, it is going to be the effective dose, right? So in this way we are going to determine. Observation: animal are observed individually after dosing at least once during the first 30 minutes, periodically during the first 24 hours, with special attention given during the first 4 hours, and daily thereafter for a total 14 days, except where they need to be removed from the study or humanly killed for animal welfare reason are found dead, right? So that's just after surgery, or after this thing, whenever the person will be keep into the observation. In the same way, we have to keep those animals for observation. First 4 hours is very important. However, the duration of observation should not be fixed rigidly. It should be determined by the toxic reactions, time of the onset, and the length of the recovery period, and may thus be extended when considered necessary. It may vary. The time at which signs of toxicity appears or disappears are the important in the case, especially if there is the tendency of toxic signs to be delayed. All observations are systematically recorded, right? So this recordation, and we will get the body weight also. We are going to check individual body weight, and whether any changes during these 14 days, that we have to. Then pathological report also we need to find it out. We have to collect the blood sample time to time if required. Microscopical examination also we have to do, right? And the data, all the data we have to collect, and those data, those reports, it is going to tell about the story, the what happened with that chemical which you have injected to test about this toxicity, right? So in the same way, 423 it is also there. In 423 it is the test procedure, right, with starting dose 5 mg per kg body weight. So here also you can see 3 animals we are taking in the 423. 420 we discussed the here 423. Here 3 animals it is there. Remaining thing it will go on in this way, depend on to the response with the chemical of the particular animal. Here it is there. It is 2B it is there. Which procedure with starting dose 50 mg per kg we have to start with the, again here also it will be citing study and main study, right? Here also Annex 2C is also there, 300 mg we can start, and we can conclude. Here you can see LD50 cutoff value mg per, so where we are getting a response with, there we can stop here in this chart, right? So this chart is going to help you. Annex 2D is there, 2000 mg per kg. So in the same way 425 it is there, acute oral toxicity up and down procedure, right? So in this way we are going to determine all the what you call different types of which dose it is toxic dose, or which dose it is the effective dose, right, for the any new chemical or any new chemical entity, right? So